Welcome viewers, in this video we will see the details of the digital logic gates. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic digital logic gates. There are two type of gates available, basic gates and derived logic gates. The AND gate, OR gate and NOT gate are coming under basic gates. The three primitive logic functions are represented by distinctive logic symbols known as the basic gates. These are all the basic gates. All basic functions are performed by AND gate, OR gate and NOT gates. So that it is called a basic gates. And another type is the derived logic gates. NAND gate, NOR gate, XOR gate and XNOR gate is coming under derived logic gates. From this primitive logic function we have derived the logic function. So hence it is called a derived logic gates, right? So in this video we will see the details about basic gates. The first one is the NOT gate. So the NOT gate is nothing but a inverter. The output is the complement of the input. The output is complement of the input. It's a symbol. This is a symbol for the NOT gate. So input A is the input and Y is the output. Output Y is equal to A bar. A, right? The input A means output will be A bar. Is the inverter. The truth table is available here. Input A and output Y. Suppose if the input is 0 means output will be 1. Input is 1 means output will be 0. It is inverted. The output is the complement of the input. The application of this NOT gate is used to complement the digital signals. If you want to get the complement of the signal mean we can use the NOT gate. Now we'll go to the next type. The next gate is the AND gate. The AND gate is the output is high only when all inputs are high. The AND gate, the operation of AND gate is the output will be high only when all inputs are high. So this is the symbol for the AND gate. The two inputs are available, A and B, and Y is the output, right? The output Y is nothing but A into B. It's nothing but a product, A into B, A multiplication of B, right? So the output will be high only when both the inputs should be high. Then only we'll get the high output. Otherwise the output will be low, right? So the truth table is available here. The input A and B, there are two inputs are available. Then the output Y, right? Because of two input we have four combinations are available, 0 0, 0 1, 1 0, 1 1. If the inputs are 0 0 means it will be output will be 0. It is nothing but 0 into 0, right? A is 0 and B is also 0. 0 1, A is 0 and B is 1, that is 0 into 1. For that case also we got the 0 output. 1 into 0, A is 1 and B is 0 means 1 into 0 also will got 0, right? If A is 1 and B is 1, both are high means we will get the high output. 1 into 1 will be 1, right? So the truth table of the AND gate is given. So the 0 0 mean we will get 0, 0 1 also 0, 1 0 also 1. Only when both the inputs are high we will get the high output as 1, right? So the application of this gate is used to implement the AND operation. Wherever we need the AND operation we can implement this AND gate. I will go to the next type, OR gate. The output of this, the output is high only when any one of the input is high. So the OR gate is OR, either OR, right? Any one input is high, then only we'll get the high output. In previous case AND gate, both the inputs should be high, then only we got the high output. Here any one input is high, then we'll get the high output. So this is a symbol for the OR gate, right? The two inputs A and B and the output is Y. The expression Y equal to A plus B, it is like a addition. Previous one AND gate, it is nothing but A into B, A dot B, right? So that both the inputs are high in order to get the high output. Here A plus B, either A high or B high means we will get the high output, right? So this is a symbol, two inputs A and B, outputs Y. Y equal to, the Boolean expression is Y equal to A plus B. Now we'll see the truth table. The input A and B, right? Two inputs are available. So we have four combinations, 0 0, 0 1, 1 0 and 1 1, right? If it is 0 0, both the inputs are 0 mean 0 plus 0 is 0 only. If A is 0 and B is 1, what will happen? 0 plus 1, 0 plus 1 we will get 1. So if any one input is high mean we got the high output. 1 0, A is 1 and B is 0. 1 plus 0 means we got 1 also. The output also high. If both the inputs are 1, so 1 plus 1 will be also 1, right? So we got that 0 0 means 0, 0 1 means 1, 1 0 means 1, 1 plus 1 also 1, right? See, this output is high when any one of the input is high, then we can get the output as high. So the application is used to implement the logic OR operation, right? Wherever we need the logic OR operation, we can use this gate, right? So one more gate is available, buffer. The buffer is nothing but the output is same as the input. The output is same as input. In case of NOT gate, the output is inverted, complemented. Here just input out, this is a symbol. Input and output will be same. The A is the input, Y is the output, Y equal to A. Both the inputs are equal, right? So the why we are using this buffer, it is used to increase output driving capacity, right? Here the output driving capacity will increase. Suppose the signal input is A means the output also Y, but the strength of the signal will increases. Buffer, the meaning of buffer means increasing the strength, that is increasing the driving capacity of the input, right? So this is a symbol. Here one small dot is not available. If small circle is there means that is a inverter. Here the circle not available is a buffer. Y equal to A, input and output are equal. So input A, output Y. Input 0 means output also 0. Input 1 means output also 1. The same output, only the strength will increase. So it is used to increase the driving capacity of the circuit, right? So in this video we discuss about the 4 type of basic gates: NOT gate, AND gate, OR gate and buffer. NOT gate is the complement. When the input is 0, output will be 1. When the input is 1, output will be 0, complement. AND gate means if all the inputs are high, then only will get the high output. And then OR gate means if any one input is high, will get the high output. Then buffer means just input and outputs are equal, only it is used to increase the driving capacity of the circuit. So in this video we discuss 4 basic gates. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.